The moon is turning its back on us. It has been doing this for billions of years. One face always pointed toward Earth, the other side hidden like a secret it refuses to share. But now, for the first time, we have forced it to show us what it has been keeping in the dark. And what we found underneath is not what anyone expected. If you want to be the kind of person who knows what is really out there before the rest of the world catches on, hit subscribe and join the small crowd that pays attention to the things hiding in plain sight. The best stories are the ones nobody is telling yet, and this is one of them. Let us start with something most people never think about, even though they see the moon all the time. Look up at the moon at night. You are only seeing one side of it. Not half in the sense that the other half is around the edge and you could walk around to see it. Half in the sense that there is a completely different side of the moon that you have never seen, and from the ground you are standing on, you never will. This is not because of some trick of the atmosphere. It is because of something called tidal locking, and understanding this is the key to everything else in this story. Tidal locking sounds like a complicated science term, but the idea is actually simple. The moon spins on its own axis at exactly the right speed to keep the same face pointed at Earth at all times. Think of two dancers holding hands, turning in a slow circle, but always facing each other. One dancer never shows their back, and the moon does the same thing with Earth. It takes the moon about 27 days to travel all the way around Earth in the exact same 27 days to spin once on its own axis. Because those two speeds match perfectly. The same side is always looking at us, and the other side is always turned away. The side we can see is called the near side, and the side we cannot see is called the far side. A lot of people call it the dark side of the moon, probably because of the famous album and the old stories. But that name is wrong. The far side is not permanently dark, and it gets sunlight just as much as the near side does. When we see a new moon, which is when the near side is in shadow and the moon seems to disappear from the sky, the far side is fully lit up by the sun. The name dark side just confuses people into thinking that side never gets light, which is completely false. Far side is the correct name, and that is what we will use from here on. For almost all of human history, nobody had any idea what was on the far side. People could see the near side with their eyes and later with telescopes, and they mapped its dark patches and craters, but the far side was a complete blank. Some imagined oceans and rivers and perhaps even a civilization hidden where we could not see. Others imagined alien bases or secret cities on the side that never faces Earth. The truth turned out to be strange in a way that nobody guessed, but we are getting ahead of ourselves. First, let us talk about how we finally got to see it. The year was 1959, and the world was locked in a tense competition called the space race. The Soviet Union and the United States were both trying to prove they were the most powerful nation in space, and each new first was treated like a major victory. The Soviet Union had already launched the first satellite called Sputnik in 1957 and sent the first human-made object to hit the moon called Lunar 2 earlier in 1959. Now, they wanted to do something that had never been done before in all of history. They wanted to photograph the far side, and they sent a small spacecraft called Lunar 3 toward the moon. Its job was straightforward, but it had never been attempted. Fly around the moon, point a camera at the far side, take pictures, and send them back. Lunar 3 did exactly that. It looped around the moon and sent back about 17 grainy, blurry images of a surface that no human eye had ever seen before in the entire history of our species. The pictures were rough, like looking through a foggy window, but they showed enough to surprise everyone right away. Here is what people expected. Scientists assumed the far side would look basically like the near side, just flipped around. The near side has large, dark patches that early astronomers called seas or maria in Latin because they genuinely thought they were looking at bodies of water. We now know they are not water at all. They are huge, flat areas of dark rock left over from ancient volcanic eruptions. Lava poured out from deep inside the moon billions of years ago, filled in the low-lying areas, cooled down, and turned into the dark patches we still see today when we look up at the moon. But When Luna 3 sent back those first pictures of the far side, something was clearly missing. The dark patches were almost entirely gone. The far side was almost completely light-colored, covered in craters and rough highlands, with very few of the flat dark seas that make the near side so familiar and easy to recognize. It looked like a totally different world. This was the first surprise, and it immediately raised a question that would take decades to answer. Why does one side of the moon look so different from the other? Before we go deeper into that mystery, here is something worth pausing on. Did you know that the two sides of the moon are so different that if you could stand on the far side and look around, you would barely recognize it as the same object you see from your backyard at night? If that catches you off guard, you are not the only one. Drop a comment and tell us which side of the moon you think holds more secrets, and make sure you are subscribed, because the strangest discoveries are still ahead of us. Scientists spent years trying to figure out why the near side has all those dark seas, while the far side has almost none. The first theory was straightforward. Maybe the far side got hit by more asteroids and comets over the years, which broke up the surface and destroyed any dark patches that might have started to form. This explanation made sense at first because the far side does have more craters visible on its surface. But as researchers studied the moon more carefully with better instruments, this theory started to fall apart. The craters on the far side were not big enough or frequent enough to explain why the dark seas were almost entirely absent. Something else had to be going on. Then came another idea, one that pointed beneath the surface. Maybe the crust of the moon, which is the hard outer shell that covers the interior, was thicker on the far side than on the near side. If the crust is thicker, it would be harder for lava from inside the moon to break through and flood the surface, which would mean fewer dark seas. This theory gained a lot of support over the years, but it was hard to prove. You cannot simply dig a hole into the moon to measure how thick the crust is. You need a different approach entirely. And that approach came in 2011 when NASA launched a mission called GRAIL. GRAIL stands for Gravity Recovery and Interior Laboratory, but the long name is not important. What matters is what these two spacecraft did and found. NASA sent two identical spacecraft about the size of a washing machine, each to orbit the moon. They flew in formation, one following behind the other at a distance of roughly 200 kilometers apart. Their job was to measure tiny changes in the distance between them as they flew over different parts of the moon. Here's how it worked. When the leading spacecraft flew over an area with more mass under the surface, the extra gravity pulled it slightly forward, changing the gap between the two. Then and second spacecraft would feel the same pull a moment later. By measuring these tiny constant changes, scientists could map the thickness and structure of the moon's crust from orbit without ever needing to land or dig. It was like taking an X-ray of the moon's interior using gravity instead of light. And what GRAIL found confirmed the theory in a big way. The crust on the far side is indeed much thicker than the crust on the near side, in some places by as much as 20 kilometers, which is about 12 miles. That might not sound like much when you think about how big the moon is, but it is thick enough to make a real difference. It means that when lava was trying to push its way up from the moon's hot interior billions of years ago, it had a much harder time breaking through on the far side. On the near side, where the crust was thinner, the lava found it easier to punch through and flood the surface, creating all those dark seas we see today. So, that explained the missing dark seas. But here is where things take a turn toward the truly strange. And this is the detail that most people remember when they hear this story for the first time. Having a thicker crust on one side is unusual, but it is not shocking. What is shocking is what was hiding underneath that thick crust, buried so deep that no camera could ever see it from above. In 2019, a team of researchers led by a scientist named Peter James at Baylor University in Texas were studying data from the GRAIL mission when they noticed something they were not even looking for. Deep beneath the surface of the moon, buried under one of the largest craters in the entire solar system, there was a massive blob of extremely heavy, dense material. The crater is called the South Pole Aitken Basin, and it sits on the far side of the moon. It stretches roughly 2,500 kilometers across, which is about 1,550 miles. To put that into perspective, that is roughly the distance from New York City to Dallas, Texas, all contained within a single crater on the moon. It is not just wide, either. It reaches down about 8 kilometers, or about 5 miles below the surrounding surface, making it one of the deepest holes in the solar system. This enormous basin was created when a massive asteroid slammed into the moon billions of years ago, gouging out a colossal hole. It is one of the oldest and largest impact structures known anywhere in our solar system. The force of that collision would have sent shock waves through the entire moon, cracking the crust and rearranging material deep below the surface. And now, billions of years later, we found something still sitting at the bottom of that ancient wound. What Peter James and his team found under this basin is what stunned everyone. Buried far below the crater floor, there is a lump of dense, heavy material that weighs about 2.1810, circumflex 18 kilograms. That is a number so large it is basically meaningless to most of us. Let us make it simpler and more real. It is roughly 5 times the mass of the entire big island of Hawaii, all compressed into a single underground deposit. Imagine taking an entire volcanic island, making it 5 times heavier than it already is, shoving it miles below the surface, and spreading it across an area larger than some small states. That is what is sitting under the far side of the moon right now, and it has been there for longer than life has existed on Earth. The question that immediately comes to mind is, what is this thing? The leading explanation is that this massive blob is a piece of the asteroid that created the crater in the first place. When the asteroid hit the moon, it was so large and moving so fast that most of it was destroyed on impact, vaporized into gas and shattered fragments. But a large chunk of heavy metal, most likely iron and nickel, may have survived and buried itself deep in the moon's interior, where it has been sitting ever since, locked in place for billions of years. If this is correct, it means we have found the remains of one of the most violent events in the moon's history, still lodged inside it, like a bullet that was never removed from a wound. Think about that for a moment. Did you know that an asteroid can hit something so hard that it literally buries itself inside the body it strikes and stays there forever, invisible to anyone looking from the outside? If you find that as hard to believe as the scientists did when they first saw the data, you are in very good company. Tell us in the comments what you think that buried metal might look like if we could somehow dig it up and hold it, and hit subscribe if you want to follow this story to wherever it leads next, because there is even more going on beneath the surface than anyone realized. But the buried metal is not the only strange thing hiding on the far side of the moon. As spacecraft continued to study our nearest neighbor over the following decades, more puzzles kept surfacing, each one adding a new layer to the mystery. One of the most interesting involves something called mascons, which is short for mass concentrations. Mascons are areas underneath the moon's surface where extra dense material has gathered together over time, creating patches of stronger gravity that you cannot see, but can absolutely measure. Mascons were first discovered in 1968 by scientists at NASA's Jet Propulsion Laboratory, a famous research center in Pasadena, California, that designs robotic spacecraft for exploring the solar system. They noticed that when spacecraft orbited the moon, their flight paths wobbled slightly as they passed over certain areas. Something under the surface was pulling on them with extra gravity, tugging them gently off their expected course. After studying the data, they figured out that these were places where dense material had pooled together, mostly under the large, round, dark seas on the near side. Now, here is what makes the far side different and strange. Mascons on the near side are strong, well understood, and fit neatly into the overall picture, but the far side has its own gravity oddities that do not match the same pattern at all. Some of the far side's gravity features are more spread out and much harder to explain. When the Drell spacecraft mapped the entire gravity field of the moon in high detail, the data showed that the far side's interior is not just thicker and more rigid. It is structured differently at a deep level, as if the moon's internal machinery arranged itself in a lopsided, uneven way from the very beginning. This brings us to one of the deepest questions in all of lunar science. Why is the moon lopsided at all? Why would one side have a thin crust with dark seas and concentrated gravity, while the other has a thick crust, almost no seas, different gravity patterns, and a giant buried metal blob under an ancient crater? The answer may go all the way back, beginning to how the moon was born. The most widely accepted theory for the moon's origin is called the giant impact hypothesis. About 4.5 billion years ago, when the solar system was still young and violent and full of flying debris, a body roughly the size of the planet Mars crashed into the early Earth. This crashing body has been given the name Theia, after a figure from ancient Greek mythology. The collision was so violent that it tore huge amounts of material from both Earth and Theia, throwing it all into orbit. Over a long period of time, that scattered debris came together under its own gravity, clumping and compressing until it formed a new body, and that body became the moon. Now, here is the part that matters for the far side. Some scientists believe that the moon formed extremely hot, almost entirely molten, like a giant ball of glowing liquid rock. As it slowly cooled, the heavier material inside it sank toward the center, and the lighter material floated up to form the crust. But the young moon was still very close to Earth, and Earth's gravity was pulling on it strongly from one direction. This one-sided pull may have caused the moon's insides to settle unevenly, so that the thicker, lighter crust ended up on the far side, while the thinner crust stayed on the near side facing Earth. In other words, the moon may have been lopsided from the very moment it solidified, shaped by the gravity of the same planet it still circles today. Now, before we move on, pay close attention, because this next detail completely changed how scientists think about the far side of the moon. It has to do with temperature, and it is something that absolutely no one expected to find. What they found hiding in the shadows would turn out to matter, not just for the moon, but for the entire future of human exploration in space. In 2009, NASA launched a mission called the Lunar Reconnaissance Orbiter, or LRO for short. This spacecraft has been orbiting the moon for years, taking thousands of detailed photographs and collecting all kinds of data about the surface. One of its instruments is designed to measure temperature, and it found something that surprised even the scientists who built it. On the far side, and especially in certain permanently shadowed craters near the lunar poles, the temperature drops to about minus 414 degrees F, which is about minus 248 degrees C. That is one of the coldest temperatures ever measured anywhere in the entire solar system. To put that in perspective, it is colder than the surface of Pluto, which is a frozen world floating billions of miles away in the distant dark outer reaches of our planetary neighborhood. The fact that the moon, which sits right next to us in space, has spots that are colder than one of the most distant and frozen worlds we know about is something that genuinely caught researchers off guard. This because cold that extreme can trap and hold on to things that would normally float away into space, and that is exactly what scientists think is happening on the far side. Water delivered to the moon by crashing comets and asteroids over billions of years may have settled into these freezing, permanently dark craters and stayed there, frozen solid as ice. If there is water ice hiding on the moon, a significant amount of it may be sitting on the far side right now, frozen and waiting. Water on the moon might not sound exciting at first, but it changes everything about our future in space. Water is extremely heavy, and carrying it from Earth up into space costs a fortune. Every single pound of water that we launch into orbit costs thousands of dollars on a rocket, and if water ice is already sitting on the moon frozen and waiting to be used, then future astronauts would not have to bring all their water with them. They could dig it up, melt it, drink it, use it to grow food, and even split it apart into hydrogen and oxygen to make rocket fuel. The far side of the moon, the same side that was hidden from us for almost all of human history, could one day become a fuel station for spacecraft heading deeper into the solar system. Now, here is a question.